here. We have the table very close to the laptop screen so we can get the video. So I don't have much room to work here. But thanks everyone. Hope you had a good lunch. Welcome back to KBMP. We have our next item is going to be a panel discussion on dam removal and the science and monitoring behind it. Really excited about this one. I don't want to overhype it, but I'm still excited. That's just me. So we have 2 members of the 5-member panel here in person, and we have 3 other folks who will be joining us online. Thank you, Atmospheric River, for making this a little more difficult, but I'm sure we'll make it work, and I do appreciate the Atmospheric River. So let me grab my paper real quick. On the panel today to talk kind of about this dam removal and just kind of reconnecting the Klamath River. We have Mike Belchik from the Yurok Tribe. We have Chauncey Anderson from USGS. Jenny Curtis from USGS, Tommy Williams from NOAA, and Dave Coffman from RES. So we're going to start with some opening considerations and thoughts, and we'll go in that same order if that's okay. And we just want to, kind of lay the groundwork here a little bit before we get into, kind of discussion and question and answer period. So really hope this is valuable for everyone. I'm going to Mike, I don't believe you have any slides to present part of your opening statement, but go ahead and unmute yourself when you are ready.
Good afternoon, everybody. Can you hear me? I'm also, excuse me, suffering from some voice issues, but I'll try to power through here. So my name is Michael Belchik, and I'm a senior water policy analyst working for the Yurok Tribe. I've been working for the tribe for about 27 years now and been working on the effort to remove the Klamath River dams since its inception somewhere just after the year 2000. I think it's important to understand where the Yurok Tribe is coming from this. And the Yurok Tribe gave their fisheries department, including myself, a simple mission, and that's to restore the Klamath River Basin, including its fisheries. In fact, it turns out to be a pretty complex mission because in order to do that, we needed to think big. And so one of the things we latched onto was dam removal. And I think even in the beginning, we didn't quite understand how far-reaching the implications of these dams were and what the implications for removal were. Dam removal is not a cure-all, but it does integrate and reconnect the Klamath Basin. And when you look at the efficiency of restoration projects around the Pacific Northwest, the removal of fish passage barriers, either through dam removal or culvert replacement or re-engineering of channels or what have you, is one of the most effective ways to restore fish. I think one of the things I want to impress on you is how I came to learn that the dam removal effort and the philosophy behind it is an extension of the traditional environmental knowledge that elders already knew. In fact, I find this to be true over and over again as a Western scientist, that the things we purportedly learn were already known, maybe not in the exact same language or format, but known by tribal elders. And integration of the river systems no different. In terms of dam removal on the Klamath, we saw right away, like I said, that this is important, but I want to talk to you about integration and reunification here. First of all, fish are a great integrator of the river, river systems in general. They transport nutrients to the upper basin. They're an important ecosystem integrator. And I think that when fish arrive back at the upper Klamath Basin, it's going to be a profound change for all the animals and ecosystems in the Klamath River and as well as the people. The water management and the water too is a great integrator that will all be changed by dam removal. So we talked a little bit about that earlier when a question got raised about summer base flows. And I do have some thoughts about how that might change in a post-dam removal world, but clearly it's going to be quite different. with Keno now as a compliance point and the flows at Klamath, at Iron Gate, allowed to fluctuate much more naturally. Sediment, as Jenny's about to talk to, is another way that the Klamath Basin will be integrated. Nutrient and nutrient dynamics will be far different. And I really loved Laurel's presentation earlier, and I look forward to seeing how that changes. And dynamic nature of the ecosystem is also going to be integrated up and down the basin. All of this leads towards the ecosystem and has profound implications for restoration strategies, prioritizations. We'll have new areas to think about. What about Spencer Creek? What kind of shape is it in? Right now, it's not of a big concern to the lower basin, but soon it will be, because that's going to be coho habitat and Chinook habitat. And what about the condition of the Williamson and Sprague? And what about the nutrient dynamics in Upper Klamath? I think folks at the top of the basin and the lower basin are going to find that they have some shared priorities now, and the salmon and the lamprey and other critters are going to be the great integrators in this. And I think it's going to be a profound change. I'm hoping that it will be a profound change in the way that we think about the basin. What I'm trying to say too is that in addition to the ecosystem and natural system implications, there are profound implications for culture, indigenous cultures, Western cultures, agriculture, farmers. Everybody will be forced to be thinking in a more integrated way, because salmon will now be integrating the Klamath Basin. And all of this, what I'm hoping to, is going to lead to a reconnection of the upper and lower Klamath Basin in ways that we can't even foresee right now. We can talk about what it, salmon showing up in the Williamson, but until you see a 25-pound Chinook spawning in the Williamson, it just, the full implications won't hit anybody until then, including myself. So I look forward to talking about this more and helping to integrate all the science disciplines and traditional environmental knowledge that's gone into these efforts. Thank you.
Thanks, Mike. The next person to help reconnect the climate for us will be Chauncey Anderson, USGS.
Go ahead, why don't you do it? Thanks. While Randy's getting that up, I'm not sure I heard him say this, so I'll maybe repeat what he might have said, which is that our plan here is for us to talk each for about 5 minutes. Just keep it short, put some ideas out there, and then open it up for discussion. Again, we kind of settled on this idea of reconnecting the Klamath, and so that's going to hopefully make its way through all of our little talks. We did not practice this all together, so there may be some overlap, but you might see that common themes are also mean something too. So I've got a couple slides. I'll try and do them pretty quickly. The basic idea is, I'm good here, I think. Oop. Yeah, I think I can do this. So the basic idea, should I just try? Let me do one other thing. All right. While Randy's doing that, most of you have heard of the river continuum concept, and I'm not going to go into any details here, other than to say it's a commonly cited conceptual idea from the 80s. Very important kind of in understanding riverine ecology. The Klamath River has a continuum similar to other rivers, but it's also got some important differences. And even in the absence of the dams, and even before European settlement, the upper basin was a different sort of beast. We talk about it as the river upside down. It's got the big break in grade, Upper Klamath Lake, all the wetlands. So it doesn't necessarily fit what's shown on this diagram. And of course, this is a generalized diagram, so some of the fish species aren't appropriate for the Klamath. But the big thing, I got you. The big thing that we have here is, the dams in red are this kind of big disequilibrium, and I think we lost our projection here. Okay. The dams provided this disequilibrium, which we are now endeavoring to try and bring back the connections.
Oh, I see what they did here. No,
I'm getting distracted by it.
There's only one screen now. We're good.
Okay. All right. So so that's the main point. The Klamath continuum has been interrupted. We're moving on as we take these out. And now I want to talk about the head spinning conceptual models that Desiree so wisely avoided. So if this go to the next one.
Oh, you want to do this?
Yeah, duplicate.
There we
That
go.
should do it.
Okay.
Go to the next slide.
We're trying to get the same thing here. Okay, so this is apologies to Desiree or to others. This is a common or this is a schematic diagram that came out of a Belmore paper and others from 2019. And I'm going to try and simplify it a little bit by focusing on the things in blue, which aren't part of the original paper. I put those in to sort of help pay attention to just a couple different pathways. But the idea is that this diagram shows linkages between different pieces of the ecosystem. And so from a reconnecting standpoint, this is a good conceptual idea for conversations around what is going to be reconnected and how are they going to be reconnected. And so as you look at this, I'll just give you a quick background. The plus and minus signs are just really about the sign of the interaction. I've put blue boxes around some of the functions in the river. And then the kind of more oval shaped boxes are sort of about endpoints. And in blue, I added in tributary inputs, which are not really talked about in the original paper, because we have 4 reservoirs with tributaries that come in the middle of it all. And this is, by the way, is for the reservoir reach. I've got one more for the downstream reach. And then the other thing that the original paper doesn't talk about is the sediment and nutrient flux out of the reservoir reach. Particularly, it talks about you know, vegetation and consumers and things like that. But I really kind of wanted to focus on the benthic producers and consumers, which I didn't coordinate this with Desiree and Laurel, but in fact, that's where I think one of the big changes is going to be in the river. And so in blue, you see the sort of the functions of the network connectivity, water depth, water velocity, and then the sediment pathways ultimately are going to lead us to changes in the benthic producers. Obviously, this is the reservoir reach, so we're going from lakes, lacustrine environment to a flowing river environment. We're going to have more light getting in ultimately to the bed, things like that. And I'm leaving the fish alone because Tommy's going to talk in a minute. And then we have the downstream reach. And there we go. In this particular case, I've again highlighted a few things kind of in the middle that are processes that are going to change. So we'll see a change in the flow regime, which, by the way, we can have a good discussion about that with Mike and others. It's not necessarily going to be a natural flow regime in this basin. There's going to be a bunch of deposited reservoir sediment that's going to move out. Obviously, we're going to have nutrients and organic matter that are moving. We're going to have changes in turbidity, and those will have short-term and long-term effects on vegetation. And again, the benthic producers. And very important in this river, we have ongoing tributary inputs of various things that provide energy to the system: flow, sediment, nutrients, carbon. And we have these things moving out in the short term and in the long term. So I kind of added this additional flux down here. And just from a connectivity standpoint and thinking about how dam removal is going to change things, I really kind of wanted to focus on the idea of linkages. This provides a good opportunity for us to talk about collaboration, to talk about science that's being done and monitoring that's being done that can start fitting together. Everybody's going to have their own little pathway that they're looking at, but then we can start linking these things together. I also added in the fish disease piece here, which kind of fits right in the middle of this whole mess downstream. And we can talk about that later, but that's an obvious linkage tying back into Sasha's talk earlier and Desiree and Laurel's talks as well. So I'll leave it at that.
All right.
And I think we have Jenny up next.
Jenny, you're on.
All right, can you hear me now?
Yes.
Yep.
All right, hi again, everybody. I wanted to talk about how reconnecting the river longitudinally is expected to restore naturally dynamic physical processes, both within and downstream of the reservoir reach. And of course, this is going to be, in quotes, to varying degrees. So Chauncey just showed those diagrams. I like to call them spaghetti diagrams. Spaghetti diagrams that describe the physical and ecological linkages and responses. And this simplified conceptual diagram basically focuses on two fundamental variables: transport capacity, which is shown on the left y-axis, and sediment supply, which is shown on the right y-axis, and how those change longitudinally with increasing drainage area, which is shown on the x-axis. So drainage area increases to the right, and you can see that there's a point at which the two lines on the diagram cross, and this is where we get naturally dynamic conditions. So the river continuum concept applies here. The river response, expected response along these two lines, continuum lines, will be dynamic. And so this is just a good conceptual framework to think about transport capacity, which is a function of discharge, and boundary shear stress, which actually does the work, the geomorphic work, and how that is correlated to sediment supply, which is the size and amount of sediment available for transport. So physical response to dam removal depends on the nature of the sediment that's in flux, the hydrology during and following dam removal, but it also depends on the nature of the river itself. So I wanted to take a couple minutes to just describe the physical template of the river upon which the ecology has evolved. So, you know, I'm a geologist, and so my timeline for things is longer than many people. So over the past million years, the Klamath Mountains were created by tectonic uplift, and that was during a much wetter climate period. The river has since incised to keep pace with that uplift, and within this, geologic disturbance, tectonic disturbance, there's been numerous other physical disturbances that are just part of the history of the basin. Fire, floods, drought, landslides, debris flows. These are all common in the Klamath Basin. And the ecology has evolved with this physical disturbance. The current river is currently not self-formed. It's confined. Most reaches are confined by bedrock outcrops. And so the river is considered partially alluvial, but the alluvial character increases downstream of Beaver Creek. That's based on work that I did recently with the Fish and Wildlife Service. Dam removal is expected to restore naturally dynamic physical processes to varying degrees, but it's also expected to restore or increase the alluvial character of the river. So we expect short-term bed fining followed by bed coarsening as the pulse of the river sediment, reservoir sediment moves downstream. But it's all dependent upon this dynamic relationship between transport capacity, which is driven by the hydrology and the morphology of the river, and then the sediment supply. So all of this is a good setup for Tommy, who's going to talk about fish.
Thank you, Jenny. This is a great setup for me. Of course, I'll have to tell everybody I set up the order, so it was set up well for me. So it was perfect. I'm going to talk about the fish perspective of this, and what's happening is we're doing a large restoration activity, as Michael talked about, and we're taking a very static system and making it more dynamic. And it's absolutely critical fish. Animals persist by tracking changes in the environment, whether it's strain, juvenile movement, life history diversity. And that diversity and complexity relies on a diversity and complex habitat. And so for a very easy schematic to think about and what kind of underpins my approach to looking at restoring fish in that system is that these fish have a capacity to track environmental change. And if something changes, these fish move across the landscape. We have this internal capacity. The fish have this in capacity. The habitat does. If we go to the next slide. What's happened in the Klamath and elsewhere is we've constrained the capacity. We've shrunk everything down. And so the capacity of these fish to move across the landscape, we have disconnected the landscape. They can't either get upstream or downstream to cool water. They can't move in tributaries. They can't move to side channels. We have constrained that capacity. And so what we're doing in a restoration activity, and one finally at a scale more appropriate to address the damages we've done to the basin, is releasing these constraints. I will say a challenge for us from a monitoring perspective is that if we do our job well, we're going to make things real complicated and messy. And also that we're going to shift how we monitor. And I think that was some of a theme in the earlier talks today. And if I can see the next slide now. We're going through this constrained system. So we have challenges from a monitoring perspective, but also I would challenge folks to look for opportunities for the research, and that we're going to be going across these systems as we bring the system back up and understanding how the system responds. These fish have never seen this system before in the upper basin because it's been so modified since they've been there before. We haven't been monitoring in a system that's going to be free of Iron Gate, Copco 1, Copco 2, and JC Boyle. And so we are going to have to find ways to monitor, to understand, to inform through these changes as we have event-based, high flows, low flows, and the passing of the seasons and post generations of fish coming back, dams out. So this is really a challenge, thinking about monitoring and management as we release these constraints. I welcome the challenge. I think it's going to be great, but it's going to require a lot of work. And I think for the KBMP meeting, this is an opportunity to think about how we move forward, because what we've done in the past 20, 30, 40 years is going to have to evolve and track change. And just like that, we're reconnecting the system. We need to reconnect our thinking and think how we do this. So for that, I will pass it on to Dave, who's going to tell us how we're going to do this and check it off as we take the dams out.
Yeah, you can exit. That's fine. Thanks y'all for having me. Dave Coffman, Resource Environmental Solutions. This is my first KBMP meeting. So again, just very happy to be here. Very excited about all the things that are going on in the basin from a monitoring and science perspective. And like Tommy said, things are going to be changing here pretty rapidly, pretty quickly over a relatively short period of time. So you think about things. I ran through a couple scenarios with my wife who's in a similar field, and came to the realization last week at one point that with what will be a very successful implementation of dam removal and restoration on the Klamath, I'm the only person I can think of that has been through the initial planning phases of building new dams and all the permitting and implementation of mitigation for dams through the planning, design, permitting, and implementation of removing a dam and doing the restoration and then monitoring and maintaining that system. So it's an interesting perspective on being able to take the dam construction side of things and match it up with the dam removal side of things, where it's all about time scales, right? So back to what Tommy said, and going back a little bit further to what Jenny said. So Jenny's a geologist, and I'm a geologist, and geologists just work on a different level of time, right? And have a basic understanding of the amount of time it takes for systems to change physically. With dam construction or with dam removal, we have a very rapid change to a somewhat dynamically equilibrated setup, right? And so on the Montgomery and Buffington slide that Jenny was talking about, you find this dynamic equilibrium between sediment and flow, right? And when you build a dam, you immediately take that dynamic equilibrium and you shove it into a different regime where you now have more flow than sediment, right? In the case of the Klamath, we're going to go from a setup where we've got relatively static conditions right now with dams in, right? Something that we fight against every year, which is these static conditions of clear water discharges at a very set rate out of Iron Gate Dam, moving on downstream. These dams come out, we're going to have an influx of sediment that the river hadn't seen in a ridiculous amount of time. Probably since the last ice dam broke, last time a glacier threw a tongue across the river, who knows how long ago, a couple tens of thousands of years ago. And so when Tommy talks about rethinking, I'm gonna paraphrase and talk about rethinking the monitoring status quo, which is when you do things for a certain amount of time or a certain period of time the same way, and you get into a groove and you start to see results, something in geology, right? In geologic time, something catastrophic always happens, and organisms, creatures have to change their approach to life. And we're fixing to come up on a point in time where we need to change our approach to monitoring, where we're going to go from relatively stagnant conditions where we understand what's going to happen, every January, right? And sometimes every June. We've got these ebbs and flows of natural responses to an artificial condition, where this new condition is going to be drastically different from the one we've got now, and it's going to change on a pace that if we're not ready to catch it, we're going to miss so much cool stuff that's going to happen. Mike talked about the amount of time he's been working on the project, and there's been, clearly folks that have been working on this project for decades. I've now been working on it for a little over 3 years, full time, and I'm just scratching the surface on things. So, Rez, we're very excited, clearly, about what's going to happen and the opportunities for monitoring and data collection to see what truly happens to a system like this when dams are removed. We've watched it on, other dam removal projects, clearly nothing of this scale. And on the West Coast, when you do dam removal, you have a lot of coarse sediment to deal with. Here in the Klamath, we have a lot of fine sediment to deal with. So it's going to be a different setup. And we're just happy to be at the table and be able to provide a little bit of a foundational baseline for the organisms that are going to be recolonizing the reservoir footprints, the main stem Klamath River and the tributaries within the reservoir footprints, give them a place to hang out, start that, in a sense, kind of start the river continuum process over for the main stem and the tribs, and the evolutionary process of this lower upper basin segment where it's been impacted so heavily for the last 100 years. So, Tommy said, and Randy said, I am here to answer questions about primarily restoration and dam removal if they come up, but do know a little bit about physical river processes too, if the need arises.
All right. Just given that the panelists here have had a chance to hear each other's opening statements, is there any kind of additions that folks want to add in terms of saying something that might not have been said? Maybe a quick question for Jenny on your one chart that you showed. Where's the Klamath on that? I don't have it displayed right now, unfortunately. But where did it fit on that on those axes in the circle where the lines combined?
I'd say it depends on
Yeah.
So because it's a continuum, there are supply limited reaches and transport limited reaches. So in general, you can think, the x-axis is drainage area. So generally, you have higher transport capacity with a lower drainage area. And then as drainage area increases, you have larger sediment supply. I can put it back up if it would be helpful. Or one of the spaghetti diagrams. Love those too.
Or we could just see what the people want to talk about.
Yeah, totally.
Yeah, and I'm also, I assume people may want to know what the latest is in the process of the dam removal and permitting, and I'm prepared to answer questions about that if folks want to also.
So you want to open it up? To
Mike, what's the latest on the?
Well, I think everybody knows that the environmental impact statement was finalized in late August. The 30-day cooling down period as delineated by the NEPA law. The latest, what continues to happen since then is a series of final permits being approved and checklisted. So the first big one that was approved afterwards was the National Historic Preservation Act, Section 106. That was the result of a very long and complicated tribal consultation with the state of California and many Indian tribes up and down the Klamath River. That was finalized and approved by FERC. That was a major milestone. Just last week, the Section 10, the Clean Water Act Section 106 permit was submitted as final by the state of California. And much thanks to Maya Singer for her work on that in the CEQA document. In addition to that, there's a lot of other sort of ancillary and smaller permits, eagle take permits, bat remediation plans, fire mitigation plans, and then a whole host of local construction and access permitting. And all of those are being worked through one after the other. We are expecting possibly today or tomorrow some indication by FERC of whether or not we'll be on the docket for the meeting in a week from now for final license surrender order issuance. The final one was the Section 404 permit for the dredge and fill permit for the Army Corps of Engineers. And I think there was some sort of the Army Corps saying, no, we need the surrender order to issue the 404 permit. And then FERC saying, no, we need the 404 permit to issue the surrender order. My indication is that they're working that out. They're figuring out a way through that. And that's not going to cause any further delay. If all of that goes through and we do get a license surrender order in November, then probably there will be a notice to proceed sometime in early January for a lot of the pre-construction work. That includes strengthening of roads and bridges, preparation of construction sites, moving the water supply for City of Yreka, and last but not least, a pretty major project to move the hatchery from Iron Gate up to Fall Creek. That includes transport of a lot of live fish eventually. But that should all commence in a couple of months, assuming FERC approves a surrender order this month. I would point out this has been a very long road. This is pretty exciting to be this close, but nothing's done until it's done. So let's just let's cross our fingers and get this thing to finish line. That's how I'm feeling right now.
All right. Well, what I'd like to do is, be able to hear from folks in the audience. If you are in the room and have a question, feel free to come up towards the microphone. Online on Zoom, if you have any questions, use the raise your hand feature, which is under the reactions button. There's the chat also, which we can look to see if the chat is okay. That's not a question. This is really the time for us to just to ask some things. We've got very little time until the dams start to come out. One question I have is, with all the monitoring that is going on between all the different groups, what are we missing? Is there anything that, in terms of a data set, is there anything that, we look back and we say, oh God, I really wish we would have collected that. And that's just a question maybe to prompt the audience for anything specific that they have questions about, or if any panelists want to, take a guess at what we might be missing.
There's Clayton's got his hand up.
All right, I'll leave it to Clayton to have a good question. All right, Clayton, go ahead.
Well, it's not so much a question as it is, we've done a lot of incredible analysis, and these papers today have been amazing. But one of the things we haven't done is adequately analyze the data that we've been carefully collecting as part of, and combining that data with the interim measure 15. We have several different longitudinal sites over the period 2009 to 2020 at this point, probably maybe 21. And it would really behoove us before dam removal to capture that data set along with all the incredible data that the tribes have been collecting with their data sondes and combine those, because a lot of the conceptual models we've looked at today regarding respiration and other aspects of river metabolism and the way the river operates, we have a fair amount of information to look at the existing conditions. And as all the panelists have said, this is going to be a very changing dynamic. And so I'm hoping that we can make better use, and it's not anybody's fault. It's a matter of money and time and effort, but it seems to me that we should make it a priority to better assess the data that we've already collected, especially relative to these amazing conceptual models that people have been sharing with us today. It's more of a comment than a question, but maybe one of the panelists can speak to that. And Randy, I know you've been trying to make headway on that, and it's a really difficult quality assurance when you're combining data from a lot of different sources. But if somebody could comment on that, I'd appreciate it.
Do you want to talk about the IM-15 stuff?
I'll let you have it.
Okay, well, I was going to say, we in our group at the USGS are working towards sediment flux estimates right now for baseline conditions. So we're not there yet. We've been collecting data for several years, and some of the statistical relationships that we are trying to use still have suffered from lack of data, from essentially lack of storms, and ability to sample, especially during COVID and things like that. So we are hoping that during this year, we will get some sediment flux estimates out, as well as some of the geomorphic things that Jenny's been working on. And maybe, in fact, I'll just say, maybe Jenny could put in the chat. She has just recently released two major data sets on a geomorphic map of the river and also a vegetation map of the river. So those are publicly available data that are now online.
I'll do that. I mean, once I find them, so I'll pop them in there.
And I know that we've also collected pretty detailed, comprehensive LiDAR, topographic and bathymetry data of the entire river pre-dam removal. This data is a couple years old now, but after flood, so it should be pretty good still. And I'll try to get that. I know I have that link somewhere.
Jenny probably has that too, and that's definitely, we use that as part of the geomorphic map process.
Right.
So those data are definitely being used.
Yeah. So it is available in two places. The Yurok published it on Open Topography, and there's a link to the Open Topography data set in our data release. We utilized the data and interpreted and calculated some land surface parameters that might be of interest to people. So I'll put those in here.
Clayton, is your hand still up, or is that a legacy hand?
My hand's still up. And I don't mean to interrupt what Jenny's saying right now, though. Jenny?
Nope. I'm happy to talk about data, data that's available, but I feel like we can share that out better in the chat, as things come up. So yeah, I'd like to keep the discussion going. So
right. Well, this is related to that. And this, as we're developing these geomorphic models and sediment transport and, all of this, and we're coming down to really changed flow conditions, and we have the biological opinion, but we really don't understand what the potential are for environmental flows under optimized conditions. And I'm working with Maya and others to develop sort of large scale conceptual models, much like you all have shared today, on some of the issues related to flow and use and conservation, and whether or not there's potential there under these lower flow conditions, these change conditions. Is there more environmental water? Now, a lot of good work was done on that by Mike Belchik and others as part of the KBRA, and the KBRA is supposed to be an unspoken thing, but it shouldn't be. It was incredible work, and we need to be thinking about flow for this restored river and how we might optimize those flows once the dams are out. And I think that may be a missing piece of our thinking in the upper, from the upper basin.
Okay.
If I can get to one other point that came up earlier, just briefly, Randy, you asked about what are we missing? And I'd say, stay tuned. We've got this dam removal workshop that we're moving towards. I think we all have ideas of what is maybe missing right now. And I mean, we can talk about that now if you want to be, it's a conversation that can go on for quite a while, but the workshop in January is really intended to get at exactly that question. And so, I mean, any of us probably have throw out some ideas of things that Jenny mentioned earlier. We're not doing a great job on deposited sediment in the shallows. That's a hard place to get at. And so, that's a good place that somebody could do some tangential research to the sediment work that we're doing.
I think it might be good to mention the water availability work that the USGS is engaged in at this point, just to try to follow up on Clayton's comment about environmental water availability for biops post.
Okay, that's an interesting one, and I don't know if Liam is on the line. I think he probably is, if he wants to address that either. But one thing I think I would say, maybe even before any of the USGS work that we're trying to plan, is the reclamation natural flow study will also have a bearing on that. And I don't know my way around biops, so I would defer that to anybody from Fish and Wildlife Service or NOAA Fisheries or Mike or somebody else on that.
But suffice to say that the Bureau of Rec and the USGS are engaged in some water availability science. And that information will be hopefully available to inform.
Two different efforts to really better understand how much water is available from things like snowmelt, groundwater processes, and other runoff and things like that in the upper basin, coming into Upper Klamath Lake, and then relationships to flow management decisions and some things like that. Reclamation's further along than we are, but
I think that's important to mention because we're talking about this reconnection and that free flowing river concept. The river is still going to be managed, as Mike eloquently explained. So we will still have water management happening in the basin, but there is some opportunity for revisiting the KBRA and the work that Mike and others did on environmental water in that document, and then trying to translate that into dams out, a dams out world. So we're interested. I'm interested in that concept. Not working on it too much right in the moment. Focused on sediment right now.
Right.
So if I could respond to that. So I get what you're saying about the KBRA. That was a more of a comprehensive agreement that rolled in restoration and dam removal and lots of things all together. I'd say right now, our focus, the tribe's focus, is not on KBRA or recreating anything from the KBRA, although I'm not saying it wasn't good work at the time. But our focus right now is moving forward into a post-dam removal world. Beyond issues like quantity and things like that, there's also just the simple management of the water, which is going to be a lot different than it is now. Right now, Keno Dam is managed for water level only in order to keep certain infrastructure working for the agricultural project. And the flows are allowed to float quite a bit as these canals are turned on and off. And then the hydroelectric project's able to just sort of soak up all that variability and release, for better or worse, some sort of steady flow at Iron Gate. That's no longer going to be the case. Keno's going to have to be managed for steady-ish flow. And as the water level is going to be maintained, and that means that Link River is going to have to soak up that variability. Link River has some really old, antiquated controls. It's not automatic gates. People got to get out there with cranes and pull flashboards. It's you know, something straight out of the 1920s still. And so you know, just the mechanics of the water management are going to be different. As far as the amounts, you know, because there's a water project and there's considerations like lake levels for Kaptu and Chwam and other things like that, the actual management of the flows is a human choice overlaid on top of climatology and climate. You know, the climate dictates certain sideboards, which you can't violate. You just simply run out of water if you release too much early, for example. But nonetheless, the day-to-day flows or lake levels or deliveries to agriculture is a human choice. That has not been set. Bureau of Reclamation, as far as I know, doesn't have any of those plans. I view this as a fairly separate issue than dam removal. It's something that is related because we're going to change a compliance point. It's not directly tied in because the dam simply didn't have the storage. You know, all of those, you know, Iron Gate and Copco and JC Boyle put together at about 60,000 acre feet, give or take, of storage. But of that, really only about 15,000 acre feet was active storage that was readily accessible. That's enough to change flows for a couple of weeks by a couple hundred CFS here or there. Certainly was never enough to do anything seasonal or especially annual. All it really could do is sort of smooth out the rough edges. The good news is that some of those rough edges, in other words, flow variation at Iron Gate, is desirable. It's something the river's been missing. And we release relatively steady flows at Keno, which was probably the natural state given the wetlands and reefs and marshes and things up there that act as sort of a shock absorber for flows. Then if there's more variable flow at Iron Gate, it's all to the good. It's all to the better for the fish. It's much more natural. I don't think we're going to see a ton of variability. There's not a lot of really big tributaries in there, but we'll see some more, you know, earlier fall freshets, for example, that, but nonetheless, I do see these two issues as fairly separated from each other. And one thought is that under the new sediment regime, new channel shape and things like that, it is going to be interesting to see if and how, like if we were to reassess the flow versus habitat relationship and the needs of the fish post-dam removal, how that might or might not change. And I'll just leave you with that thought. That's work that has yet to even be started.
I've got something to add since I'm on the virtual world here. There's a couple questions in the chat. One of them is probably a good one for Dave about, is there an effort to identify geographic features altered during dam construction for possible restoration? I'll let him answer that, but I know a lot of effort goes in looking at old photos and notes. The other one from David that is about looking at acoustic terrestrial interactions. Those are one of the questions that is probably exactly what should we be doing now, and would be a topical in the meeting in January at Humboldt, is that no one that I know of has done a systematic sampling of marine derived nutrients in the upper basin. And these are the kind of things that we're looking for. You only get one opportunity to do that before we reopen it up. And so those are the things that I think that will be discussed at that meeting at Humboldt to try to capture that. So with that, let's see if Dave wants to address that question about how do they ensure they know what's there. And that was an issue on the Elwha at Guines Canyon, but Dave can talk about this.
Thanks, Tommy. Just scrolling up so I can see. Identify geographic. Okay. Is there an effort to identify geographic features altered during dam construction for possible restoration? Not right now. There's not. It's more of a wait and see what comes after dam, during and after dam, right? So we're going to have a period of time Dam removal is not something where you snap your fingers and it's done. Dam removal is a couple month process where we're going to have some very interesting conditions to contend with, to get into these reservoir footprints and try to get our heads wrapped around what's there, right? We've talked about lava dams and reefs and falls and all these different things, and recognizing that those were natural barriers for fish passage that behave differently at different times of year under different flow regimes. We've identified the locations of some. There's a pretty significant falls within the Wards Canyon bypass reach. There is one in the vicinity of Copco 1, and for all we know, the historic diversion dam or coffer dam that diverted water into the diversion tunnel around the left abutment of Copco Dam, took advantage of that feature when it was constructed. We just don't know. The Moonshine Falls feature appears to have been, if not modified during dam construction, modified certainly as a result of clear water discharges after dam removal.
Where's that?
Immediately downstream of J.C. Boyle.
Okay.
And so Ted Wise did a really good job of tracking down some historical photos to find the location of Moonshine Falls. And we've been able to revisit the same vantage point of where those photographs were taken. And it's a different condition now than it was immediately pre-dam construction. And so part of the data collection effort, or I'd say a secondary outcome of the data collection effort, is needed for restoration design and for monitoring sediment discharges from the reservoirs. We'll pick up the information that can be used to identify more of these features. We've also got a very robust fish presence and fish passage monitoring program that's going to extend from the upper end of J.C. Boyle Reservoir all the way down almost to I-5, where we're going to pick up at least annual for 5 years, Dan, surveys, topographic and bathymetric surveys of the river channel post drawdown. And so there's going to be just an incredible amount of geospatial data collected over the course of 7 years. I just got 7 years. Okay, so we've got a few years of multiple data sets per year, and then 7 years total of topographic data collection. So an incredible amount of information to do those deep dives and to check into those things. And those data will be available to the public for review and to the research community. So I will say more things coming, but that specific effort that you asked about is not anything that is officially part of the project.
I do want to
Can I
jump
add
in
to
there,
that?
though. Yeah, and I'm going to jump in real quick, Mike, and then I'll pass it to you. Is that I want to make it clear, though, that the historical records, the indigenous knowledge, we know that anadromous fish got to the upper basin. We've done surveys of Ward Canyon. We know that it was passable by steelhead coho. Lamprey, there's nothing in there now that's not a fish passage. And of course, things change at higher flows and lower flows. But to be clear, we do have strong historical from the 1800s on and traditional indigenous knowledge letting us know the general distribution of anadromous salmonids in the basin.
So just, I definitely, Ken, that was a really good question. The Section 106 consultation did address historic geographic features and how to handle those in the post-construction, whether some of them should be marked for non-disturbance and things. And I do know that the Modoc and Shasta nations both identified places that are confidential, right? I don't exactly know. These are places that they've identified, worked with the state historic preservation officer, and those are embodied in the Section 106. So the tribes had a long time, and great care has been given to a lot of these important geographic features and landmarks that are important to individual tribes. Some of them are now submerged, and it is not exactly known how they will reassert themselves. And for that, there is quite a robust and complicated plan that's outside of my area of expertise, but it has to do with like this, discovery plans, anti-vandalism plans, and ultimate disposition of anything that might be found in there. All of this as a, like I said, result of a long, complicated, and sometimes confidential consultation with the tribes in the affected area. So I hope that helps a little bit more, because I know there's some important sites in that area for Modoc and Shasta both.
I know there's a couple questions in the chat that appear to be getting kind of answered in the chat. And so thank you for those doing that. One other point I want to make, gets back to something Clayton mentioned about the IM15 data. The interim measurement 15 data set is a big collaborative effort to collect water quality data that's been ongoing, but it is one group collecting data, one larger group collecting data. There is so many other data sets being collected, that, we want to be able to make sure people are aware of, through KBMP. We have requested in the past, kind of the metadata for monitoring locations. What are you collecting? Where are you collecting it? How frequently? Those types of questions. And we have that into an interactive map on the KBMP website. We'll be able to make that data available otherwise, for folks who need it. But that gets to the issue of, where are the gaps in the data sets? And so, I think it's really important to look at that, collectively when we have these questions and we want to ask what are our needs? What are our gaps? We want to help share the data, share the metadata so that people can access it and, are aware of it. If folks have questions about, what is available, feel free to contact me. This is Randy, by the way. Sorry, I'm on the
He's on his knees.
On the edge of the conference table.
You can come sit back here.
I could. I wasn't on the panel though. Not on the panel. But being able to at least be aware of what's out there is important. And so let me know if I can help folks find out what you're looking for. Because those gaps, if we don't know the data, then we don't know the gaps. So, any other, closing thoughts? I know we haven't talked about, lessons learned from other dam removal projects, which all are going to be very different from the Klamath in different ways. And any key points about lessons learned from, other dam removal efforts?
I'd like to make a kind of the same thing, kind of along those same lines, and kind of a request to the group in that there's been thousands of other dam removal projects in the country, over recent years, right? Nothing close to the Klamath as far as scale goes. But there are a number of other projects in the country that mirror the scale, or if not, are larger than the Klamath Dam Removal Project, that are waiting to see how Klamath works out before the next steps are taken on those. And so, as somebody who's I've spent the majority of my career adapting the adaptive or applied practice of scientific data collection to build the case for the benefits of restoration, right? I would just make a polite ask that as we're all thinking about how to frame up data collection efforts in research projects and interpretation of data, that we think about, and as recognizing that while there is a glut of money right now to do some really cool stuff on the West Coast and in the basin in particular, that the more effort that can get focused on a unobstructed and unbiased review of the benefits of dam removal, right? Starting with the big picture and moving down towards the fine, the minutia, so that when this project is a mad success in the next 5 to 10 years, we've got this slew of independent and third-party research that shows that it's not just something where dams come down and fish return, right? And we are able to document fish presence in a place where they hadn't been in 100 years. But all these other add-on benefits to the downstream system, the upstream system, sorry, Tommy, I'm going to botch this one. The ocean to river to land nutrient cycling. But all those different things, and say, hey, look, from a comprehensive view, of course there were problems with dam removal. Anytime there's a giant civil engineering project that deals with nature, there's problems, but the end result is net benefit to the natural system and the human environment. So that's just mine. Please, if you will, keep that in mind, because I know we've all, if not taken part in, at least seen research projects that are really cool research, but have trouble justifying application of anything.
So if I can just respond to that, and Tommy and Mike may have comments on that as well. Or Desiree, if she's still online. There has been, there's actually a synthesis process for dam removal science. I'd say for the most part, it's not necessarily talking about benefits as much as results.
Sure.
But so the paper, the Belmore paper that I had the spaghetti diagrams up from earlier comes from that process. There's a one by Melissa Foley et al. I don't know if Melissa's online right now. She might be. She works with Randy actually at SFEI now. And a couple others. Desiree was the author of one more from the engineering or kind of common concerns standpoint. And so those are worth, and I can put that bibliography in the chat. That's a pretty good starting point. It was current as of about 2000. Well, the Belmore paper was 2019, but a lot of that work was being done in the 2016, 2017 timeframe. Along with it, Ryan Belmore and Jeff Duda and a few others who work on the ELWA put together what's referred to as DRIP, the Dam Removal Information Portal, which is basically an online data repository for dam removals and related science. So that's available, and I can put that in there. And then, and that's been continuing to be added to. Jeff, who works on the ELWA. And then the last thing I was going to mention is the ELWA group itself has been churning out a lot of papers on ELWA, and a lot of it is science, but some of it gets to, I think, what you were trying to get at, which is the bigger picture of the benefits of the dam removal in terms of ecosystem restoration and the integration of a lot of these things. So I don't think you're wrong. I think we need to continue doing that. But there have been some pretty good recent efforts along those lines, certainly great starting points for gathering some of that information.
And the thing I'll add to that is one of the biggest arguments we run into whenever we present dam removal and restoration to folks is, well, you guys know this is the Klamath, this isn't the Elwha River, right?
Absolutely.
Like, yep, got that box checked, very familiar.
Yeah.
That's where we are right now.
No, absolutely. And I hear
so,
that a lot too.
Yeah, so it's one of those, and there'll be plenty of folks who say, well, this ain't the Klamath River. I'll say, you're right.
Everyone's different. Yeah.
And so it's a matter of framing in a way, and maybe it's simply that. It's a matter of framing up these projects and these efforts that we're doing, that they are dam removal, period.
Right.
Not necessarily tied to it. The more we can do to get away from tying things to a geography, and of course, the more projects we do, the more trends we can develop that are not geographically based.
Well, so a big effort was made in those processes in the Belmore paper and Melissa Foley's and some of those other ones to tease out the pieces that are more universal, not necessarily dependent on the individual study. There was definitely an ELWA influence. There's definitely a influence of a couple, because those are the only ones that had happened, right?
Yeah.
But we've had a few processes so far to differentiate what makes Klamath different, and that was kind of what I was trying to get at with my sort of tweak of those diagrams, is what makes Klamath different. There's actually a bit of a write-up in it in the white paper that's on the Yurok web pages from the 2020 workshop that I think you guys were at. So we've definitely been working on that, what makes Klamath different piece. And so there are some things I think in the Belmore paper and some of the other ones I mentioned that do come through. There's things that come through pretty well, and other things that definitely are very situationally dependent. And those are the kinds of things that we need to still kind of keep teasing out. Yeah.
I'll just chime in real quick, Dave. I think you're calling for sort of a all-encompassing public perception of dam removal paper, and I'm going to copy a link to a paper written by James Hinson from NASA about the perception of climate change, also a controversial topic, but he poses it as just a perfect metaphor. He calls it the climate dice, and how there's all this uncertainty and it's a probability problem. And I think the application to dam removal, the connection could be a smart one. So I'll just share that out. It's a short paper and it's written for the lay audience. So I think a lot of people might appreciate it.
That'd be great. So well, not even a caveat. I apologize to Tommy in the past, because while I've been working on Klamath for full time for 3 years, I've been laser focused on one aspect. And so I admittedly have lost track of the bigger picture, if you will, in an effort to try to get dams.
Understood. Yeah, we can't all do everything.
And the other thing being, this is coming from an experience I had a few years back in Texas, where I was asked to come and participate, same thing, kind of on a panel for post this catastrophic flood that happened in a little town outside of San Antonio, between San Antonio and Austin. And it was sponsored by local university. And we talked through it. And I got to meet all these students who were super excited about doing geography-based geomorphology and all these different things. And I asked them, what do you guys, I liked a lot of them, and I needed to hire some people. It's incredibly hard to find folks to do restoration in Texas, believe it or not. It's not as cool as here, right? And so I'm talking to them about, well, hey, what do you want to do when you grow up, right? Well, I want to go to school and get a PhD. It's okay. Why? What are you going to do? I want to study stuff. It's great. Why? So I can publish papers. Great. Why? And it was this, just what can I put my name on and say that I published another paper, right? Instead of what is for the greater good. And I feel like as folks who practice dam removal science, the greater good is removing dams into places where they need to be removed. So if we can focus our efforts on, I won't say justifications, that's the wrong word because it can be taken the wrong way, but on the practical application of removing dams and its benefits or results, right, outcomes, with a mind to the human environment and the underlying ecosystem responses. I think we will all get to see more really cool projects coming up very quickly. Tommy, got your hand up?
Yeah, I just wanted to let folks know, since I was kind of doing the fish angle, that the reintroduction of fish and the monitoring of fish post dam removal are being led by the states, ODF&W and CDF&W. And both of them have been working closely with their partners. I know the tribes, state and federal agencies have all talked to them a lot about it, often commented on their drafts. The Oregon's is out now. And that there are clear, explicit guidelines on how they're going to do it, what they're going to monitor, certain timelines for certain actions, and those things should be available. If you cannot find the Cal CDF&W plan is not out yet, I do not believe, for public, but the Oregon one is, and you can follow up with me if you can't find it. ODF&W has it, and it might even be on the KRC page. So just to know that the different groups have this out, and this leads to the other question for researchers, or the other comment I want to say about researchers is that the federal state agencies have different mandates or obligations, as does RES in terms of compliance monitoring. But for our monitoring fish or water quality, we have to do that. We can't always do all the research we want, but if you can interact or leverage the work we do to do more academic research, sometimes with a little bit more sampling or a little bit different placement of sampling, there's opportunities. And so that's what I would encourage you to do. You've heard several mentions about the spring run work in the upper basin by ODF&W, the fish health study that was talked about on disease. There's a UC Davis graduate student working on there. There's NGOs, CDF&W, ODF&W, the tribes are assisting. And that's something that the agencies push forward to get coordinated on how we're going to monitor fish, upper basin, lower basin, with tags moving across the landscape, which we've never had before. How do we manage our databases? How do we count salmon in the upper basin? So those are great opportunities for other research and monitoring that look at the obligations that our agencies have and look for ways to leverage those for your research. And we'll talk about that more at the Humboldt meeting. You'd think I was getting paid for the Humboldt promotion there.
Free plugs. Yeah. We are a little bit over time for this. I want to make one final comment. Just the wording matters. There's a few comments here about, is it the benefits of dam removal, effects of dam removal, and then going to the next one, perceptions of dam removal. So words matter. I want to thank the panelists for their words. There's a lot to learn still here. We've put the plug in for the January workshop for the comments that are here. We will be able to put those up in some capacity on the KBUP website for getting to the links that we've discussed. Have PDFs or links to important things. So we'll address that. Feel free to follow up with us if you have other, important questions. So happy to do that. Got something over there. Oh, yeah. We're kind of past 10 minutes past. What is it, Michael? Oh, okay. Come on up, Michael. We have the one microphone. Oh, notes. He's bringing notes, folks.
I'll just reiterate, or I ask, you are making these, saving these chats?
Yes.
Yeah, I have seen the chats.
Yeah. Time in there, probably it's fine.
Okay, first two questions, and they're quick. Okay, so you mentioned like Moonshine Falls, that there are, like I heard, potential basalt reefs. Are you gonna blow them since they impede the, so we're gonna take out the dams, but the fish can't go up?
Hey, Tommy, you want to take that one? Tommy's schooled me up on this, so I don't want to misquote him.
Did you hear that, Tommy?
I did hear that one. Where there's going to be actions are on man-made or human-made barriers as we do drawdown. And correct me if I'm wrong, Dave, or maybe Dan can jump up, is that there's a technical team going to be available as they do drawdown. We're going to look to see if we see man-made issues during drawdown that might cause it. We've looked at bathymetry of the reservoirs where they dug things out, road crossings. There might be some things that happen with the sediment and a hanging tributary. There are other barriers, and I think it was mentioned that are passable or not passable under different flows. That's how the system works. And that's that diversity and landscape there. And that's the challenges that make the difference between a summer run steelhead and a winter run steelhead and a spring run chinook. And those things create a mosaic across the landscape in a natural variable dynamic system. So this is not a fish ladder, just move every fish up to the upper basin. There will be evaluations, what's been done. The trickier question that I'm not sure what the answer is if there was heavy modification for the construction of the dam, what steps will we take? And I'm sure that will be, that's going to be addressed. I have a feeling that if something happened, like when they take the footings of the dam out, they've got to make sure the fish can get over that. And it'll be an analogous consideration that way. So there's no plan to just go blasting everything that we perceive as a barrier. My profession did that all over the landscape, starting in the 60s and 70s, and it really did work. We've done that experiment, and it did work. And so this just creates that mosaic. So I hope that's a useful answer. And Mike's thought about this too, and maybe he can chime in. But we do have triggers, though, to respond to something that during drawdown creates a passage issue. So
yeah, so my understanding, the whole KHSA, the Hydroelectric Settlement Agreement, defined facilities removal as removal of the structures necessary to provide for unimpeded fish passage from the managed parts of the project. So the foundation of Copco Dam, for example, or Old Coffer Dam, those will be specs in the contract that the river must be left in a passable state for those kind of things. Other things that may become exposed as the reservoirs are down will be handled just as Tommy described on a case-by-case basis.
Next quick question. So you guys thought we're on kind of a tight schedule here. In January of next year, we've had 3 drought years, but have been great for dam removal. What happens if it's next 5 winters are very wet?
So what we've done, this will be a fairly quick answer, and then we can follow up later.
Yeah.
We've run multiple scenarios for dam removal under the driest of conditions and the wettest of conditions. And in every case, and this ties back into a question that was asked in the chat, under every case, we have nothing but confidence that dam removal gets completed in the year it started. Under either scenario. If we can't work on this part of the project, we'll work on that part of the project type of thing. And focus efforts over there will increase production on JC Boyle while we wait for Iron Gate to draw down, right? So there's this
So it's
idea
doable.
that it's all doable with a little bit of flexibility and always opportunities to crank up numbers of shifts per day or timing of work to where we're going around the clock to make sure this thing happens on the time frame it's been committed to.
Okay.
And I'll
That
follow
was
up
my
with you. I've
other
got
two.
another response to that, but I'll follow up with you.
And speaking of time commitments, I'd like to end this panel to get back to our time commitments here at KBMP. I want to thank the panel members